All right, everybody. Thank you again for joining Panzura's webinar on how to stay up when your cloud goes down. My name is Glenn Schock. I'm the sales CTO at Panzura, and I have a few folks from my team joining as well later when you have questions. If you do have questions, feel free to write them into the questions portion of the sidebar or in the chat. I think that the team here will alert me if there's any questions. There will be a Q&A at the end, so we'll just aggregate them all at the end. Today's webinar is about data resilience and how to stay completely up even when your cloud provider goes down, which does tend to happen every once in a while. And we'll discuss that in a moment. But those of you that don't know anything about Panzura, we are an unstructured data management company. At our core, we are a global file system called CloudFS, and that's what we're going to be talking about today. On top of CloudFS, we have Panzura Data Services, which is a SaaS platform that allows you to do search and audit on CloudFS, as well as third-party NAS devices, we'll say, via NFS or SMB. And then lastly, on top of that, we have smart apps that we're releasing on top of Panzura Data Services that allow for edge access to your GFS, as well as third-party access outside the firewall and all the other things that we can discuss if you're interested. But again, today we're going to be discussing resiliency. And this first slide goes over the resilience that we've put into CloudFS. First and foremost, NAS, as you know it, probably hasn't changed in quite a few decades now. NAS is always seen as a box in a data center, and you have to be in that data center to get access to the data in it. Or if you're outside the data center, you have to do unnatural acts such as WAN acceleration and push SMB or NFS across greater distances. A global file system such as CloudFS enables that data to be available everywhere. That is in various data centers, that is in remote locations with intermittent access to networking actually, and also in the cloud. Right, so you can actually have cloud native access to your unstructured data. So that is one form of availability, right? We make your data available globally. That's why it's called the GFS. Within CloudFS, we have also implemented various levels of high availability. CloudFS is effectively software that installs in a VM, such as VMware or Hyper-V, or at the end of March, we'll be supporting Acropolis or AHV. So it installs on any kind of HCI gear that you have. So we need CPU, we need memory, and we need some local NVMe for caching. Should that hardware go down, we support a local HA capability. So you're effectively making a second, for lack of a better term, filer, right? We call them CloudFS nodes, but it's that head end unit that gives you your NFS and your SMB connectivity. Our back end is an object store, and that's what we're going to be talking about today, is resiliency of that back end. But on the front end, we do have local HAs, so you can create a secondary or a tertiary filer head effectively. At no cost, by the way, other than the cost of the hardware. So we don't really charge for that functionality. And you can create a global HA, and we'll talk about why. So local HAs exist if your server goes down, right? So it'll fail over to another VM that has connectivity to the backend object store, and your local data center has access to the GFS. But what happens if network connectivity goes down to an entire region? So let's say that you have San Francisco and New York and London and some stuff in the cloud, and New York just becomes unavailable. Within a GFS, the way that CloudFS works is that the local filer, where you initially created that file within the file system, owns the lock management for that file. So if that entire region goes down, that means that a portion of your GFS no longer has the ability to support lock management, which means that you can only open up those files for reads. But Panzura has implemented a global HA node that you can put anywhere within your environment, including the cloud, that will take over that lock management should, let's say, New York go down. So that when somebody tries to open a file that is managed by the filer in New York for locking, right, so for read and write access, then instead of going to the New York filer, the global HA node, when it turns on, will make the other CloudFS nodes aware that it is taking over the lock management for New York because they all agreed that New York was not available. The goal within CloudFS, and this is what's unique about Panzura's CloudFS, is that, and I've been in the storage industry for over 25 years now, I've never seen a GFS that balances reliability with performance. Usually you have something like Lustre out there, which is super high performance and very low reliability because it's made for the Department of Energy to run tests, and they'll just rerun a test, no big deal. Or it's super reliable and with really bad performance. Whereas the way that we implement CloudFS, because of those edge node designs, we have local cache, local disk, local memory and local CPU. It feels like local performance, but we've implemented so much resiliency between local HA nodes and global HA nodes that you have this mix of performance and reliability. And lastly, we're also immune to ransomware. So let's define immune first. Immunity, if let's say I've had a flu, I'm now immune to that flu. Doesn't mean that I'm not going to get the flu again. It's just that my body's going to shake it off, right? I have the ability to fight it off. And CloudFS is immune to ransomware because we're immutable on the back end. So we write to a backend object store, but that immutability is actually within the file system. We do not use the immutability or the worm functionality of any third-party object stores. So we use NES3 compatible backend, and such as obviously Amazon S3 or GCS or Azure Blob, Wasabi, as well as on premises such as Cloudian or IBM Cause. And we make that immutable. So all writes are additive. So if somebody comes in and infects you with ransomware, all you have to do is recover to the last block before you got encrypted. And all of a sudden, the ransomware's gone. Well, the encryption aspect of it's gone. Then you run a scan of your file system and you remove the ransomware and you're good to go. So these are all the things that we have done within CloudFS to make our system highly available and resilient. But the backend storage is different. Cloud providers go down way too often. AWS has had a series of unfortunate events, and Microsoft's gone down and Google's gone down. They've all gone down in one way, shape, or form from an accessibility standpoint to various levels of failure within the cloud. And we actually had a call from one of our customers that said, hey, AWS is down in this region and you're the only thing that's still up and available. How are you doing that? One of the neat things that our system's capable of doing is caching a bunch of data locally. So even if the backend goes down for like a brief minute, no one local feels that that backend is down because the cache is going to service most of the hot files within that region. With unstructured data, 90% of the data goes unused after a year, and the 10% that's hot is usually distributed between the various data centers and cached locally across them all. So for a temporary outage, they're not going to see really any downtime unless they're pulling old data, which then we need that object store for. But if that object store goes down, what are you going to do? And that has been previously a single point of failure for Panzura, even though those object stores are replicated across 3 different data centers. So if you go to a traditional Amazon AWS data center, they have 3 within a region. And if one data center in the region goes down, there's 2 other data centers. So you should be up and running. But one of the hyperscalers last year had an interesting case where they went down for 4 hours and didn't admit it, which means that nothing failed over because they're unwilling to take the downtime hit. So they just kind of like didn't admit it. So even if you're doing cross-region replication, so one of the 3 replicated instances was outside the region, they have to admit they're down before anything fails over. And this was impactful. So we have a solution for this, and that's what we're here to talk about today, which is cloud mirroring. So the goal is across the board immediate data availability. We don't want your backend cloud or even your on-premises. If you're using IBM ICOS or if you're using Cloudian for on-prem, you can also remote replicate to maybe Wasabi, right? Or a low tier within GCP or AWS or Azure. We love everybody. If one goes down, the goal is to be able to fail over to another one with no impact to your users. They shouldn't feel that there was any impact. And I'll talk about how those 2 interact with one another because of our local caching simultaneously with the failover mechanism and how we fail back. So we want to give you not only that ransomware protection, not only that local HA, but we want to also help you support the back end and have options for replicating data to various clouds. So again, CloudFS is our GFS. It's our global file system. It does go to that one authoritative data set, which is this black cloud here. And what we're going to talk about today is the fact that we can replicate that. So those of you who don't know Panzura really well, this is a quick primer on how Panzura is deployed. Again, these hashtags, our icon denotes a CloudFS node. It is, again, deployed to software, either via VMware, Hyper-V, as well as AHV at the end of March. It is deployable as a GFS, so in as many data centers, as many regions as you'd like. We are currently talking to one customer that wants 340, right? Quite large. We scale very well, and that's unique to how Panzura does our metadata distribution. So we have customers with 3 sites, we have customers with 80 sites, we have customers with 100 plus. And the way that we're able to scale is and have immediate metadata consistency is because the Panzura filers or Panzura CloudFS nodes, they push metadata every 60 seconds and they have this ring of IO in which they communicate to each other about the metadata changes within the entire GFS. We are not beholden to a central point of failure around one device, one master device, basically polling each individual node. We have constant communication between all of the nodes. That communication is very lightweight. It is non-impactful to your global network. It is simply passing of write locks. So a very tiny little bit of information, as well as a push of any changes to all the different CloudFS nodes. So when you drop a file in New York, as soon as that operation happens, you're going to get the acknowledgement from the Panzura CloudFS node that's local in New York. So the ACK happens back to the application. It's cached within the Panzura filer, and then it is committed to the backend object store. While it is committing to the backend object store, it makes, it basically sends out information to the other CloudFS nodes and makes them aware of a new file within the global file system, what directory it's in, what, a lot of different information, all the metadata associated with that file. And London's going to see it pop up. You can actually double click on that file and begin opening it as it's being dumped. Let's say it's a massive video file with a header, and the IO started committing to the back end. You can actually double click and start streaming that video file in London before the operation is actually completed in New York for writing, let's say, a 2 gig video file. Now, if somebody wants to make a modification in London and they want to open it up for read and for write, then they're going to have to request the write lock from New York, and then we're going to pass that to London. And we have a lot of metadata exchange around that, meaning what version of the file is it? Because again, we're immutable in the back end, so any changes create a new back end version, but the users only see the current, unless they have something like Microsoft VSS where they can right click on it, go to properties, go to versions, and see every incarnation of that file. And this is also how we recover from ransomware. You can go to a previous version of that file, and you can do it on a large scale, obviously. So yeah, this is how we pass our locks. The key here is, and we have other webinars around how CloudFS works, the key here is resilience, right? And every one of these locations, even though it only denotes with one CloudFS node here, you could have a local HA. You could have a global HA in the cloud, so that if New York goes down, the write locks are managed out of the cloud. And then the last bit that I want to get to is a genuinely good GFS has native accessibility to all the hyperscalers. So we are in AWS Marketplace, GCP Marketplace, Microsoft Marketplace, and you can install our CloudFS nodes within the cloud and have cloud native access to your entire unstructured data set. Think of the applications of that. Let's say that you are in all these locations, you have cameras that are dumping data locally, right? Just a video feed, and you want to do facial recognition. See if people are wearing PPE, or you're looking for somebody, or whatever use case you have. Instead of having facial recognition software at the edge, it's going to be very costly because of the amount of servers that it requires, as well as the software costs and the maintenance costs and everything else. You could be dumping video in New York, Colorado, London, and it aggregates in the object store and it becomes visible, let's say at AWS, because it's local. And then you can run recognition, which is AWS's facial recognition software. Has been pre-programmed for looking for PPE or looking for aggression or looking for a face. And that is done centrally. So you can scale out EC2 nodes to do that. So you can take your VMS system, video management system, output it to MP4, and then run your facial recognition in the cloud without having to do any edge processing, and then push, if you find the face, you can push that information to an administrator or alert whoever needs to be alerted. So the key here is think about your data not only being available in one place, but available everywhere, and what you can do with cloud native applications once that data set is available without any copy operations. So again, we talked about local HA, we talked about global HA. Now let's talk about mirroring this cloud. So in normal operation, from that previous picture, this is your primary backend object store. A Panzura filer or a CloudFS node will be write splitting, and this is unique, right? So it's not like your traditional storage remote replication. We are doing a write split between two object stores. Those object stores don't need to be in the cloud necessarily, right? Even though we call it cloud mirroring. So you could be write splitting between on-premises MinIO and Wasabi as your in the cloud as your secondary. So for every write that happens, it happens at both locations. We're only reading from the primary object store. Again, even in the second site, third site, fourth site, we're reading from that primary, but we're writing to both. Should your primary cloud become inaccessible, we are then going to fail over every node to be reading and writing from the secondary. We are also going to be caching at the edge all of the writes that need to go to the primary cloud once it comes back online. This is not a cloud migration solution. Can be used for that. It's a corner case, not intended, but we're living under the assumption on our Panzura CloudFS nodes that the primary cloud will be down for 10 minutes, 15 minutes, a few hours. And we're going to be caching all of the writes in total, right? So that when this comes back online, we can sync the primary cloud with the secondary. So again, we're still going to be reading and writing from the secondary, but we're going to sync the primary cloud, and then we are going to read and write from that cloud. Sorry. So we are going to sync it up, and then we're going to fail back. Failover and fail back are both automated. Not my recommendation, quite honestly. I would automatically fail over to the second cloud. I would automatically allow resyncing of the primary cloud when it comes back online, but then fail back, it should be scheduled, right? You don't want to just be willy-nilly going back, because if you have networking issues that make the Panzura filers feel that the primary cloud is down, up and down and up and down and up and down, you're going to constantly be failing over, failing back, and it has nothing to do with the cloud provider. It could be a networking issue, or it could be something else. So once you've failed over, my recommendation is to hand fail back through an administrative action. But this isn't just about storage outages, right? The key is availability. And this is how you have to think a little bit differently. And I mentioned this in the last slide, is that traditional remote replication, if you think about a NetApp SnapMirror, if you think about all the various offerings from Dell EMC, is if you have two sites, and on site one, you delete a file, what's going to happen in site two? It's going to delete the file, because remote replication is made for business continuity. Should site one become unavailable, we can read all of our data in site two. So garbage in, garbage out, right? File corruption happens in site one. That file corruption is going to replicate to site two, because that's the intent of traditional remote replication from traditional storage vendors. Panzura is not a traditional storage vendor, because what we're wrapping in is not only a write split between two clouds, so we can fail over one cloud and another, right? And we can also fail over locally. And because all of your sites have access to the exact same data set, if one site fails, all of your data is globally still available, because you have that global HA node to take over the write locks. But also it's for recovery, right? Because we're immutable in the back end. Normally, if you have a file deletion, you need to revert to a snap, or you need to recover, depending on how long ago it was, and you didn't notice that deletion, you might have to recover from tape backups or your disk-to-disk tape structure, or whatever you're doing. All of that is also inherent within CloudFS, right? Because we are remote replicating data. If somebody deletes, let's say in a PowerPoint, in the actual PowerPoint file, somebody deletes a slide, yes, that write is also split to both locations, but because we're immutable in the back end, you can recover that deletion of a slide by simply reverting to the previous version of that PowerPoint file, which means that we're also wrapping in backup software, recovery software, whatever you're using for audit and search, that's within PDS, right? We're wrapping in all of these features that you would normally have to go to other places for, all within one solution. And that one solution now has end-to-end availability options if it's deployed correctly. So the key here is that you are defensible, you're taking a defense posture against not only cloud outages, but also cyber attacks and ransomware attacks and networking loss and all of that. So there are scenarios that we can walk through if you want to have a one-on-one call, where you can infect our hypervisor, you can infect our file system, you can take down a machine, you can take down a cloud, and at each and every step, Panzura has an option for you to stay available, for your data set to stay available, and for it to not be corrupted. So what would you have to buy to have a solution similar to this? Most of the traditional storage vendors make you pay for remote replication of this caliber. Some offer free async remote replication, others don't. You would also have to buy some components of somebody like a Varonis to do auditing. You'd also have to buy some backup and recovery software. You'd also have to potentially create an air gap network for business continuity. Effectively, you'd have to buy a lot of stuff. And with Panzura, all you have to buy is a secondary cloud object store, which could be at a penny a gig per month, because it doesn't have to be the same performance as your primary. So if your primary is your super fast, super available, top tier GCP, let's say GCS standard, you could go to Coldline and pay a fraction of that for your secondary, or go to Wasabi and pay a fraction of that, simply because it's your secondary. It doesn't need to always be super fast, it just simply needs to always be available. At the same time, we don't need backup and recovery because we're immutable, and our customers find that out pretty quickly, that they're never recovering from a backup. They're recovering from our own file system, should there be a mass deletion or ransomware or anything along those lines. And then lastly, we don't charge for CloudFS, right? So there is no cost associated with CloudFS, cloud mirroring feature within CloudFS, because we feel that remote replication and that kind of availability is a right. It's not a privilege for people that can afford a six-figure price tag for a secondary site. So all I have to do is turn it on. It's available in 8.1. Okay, so that was half an hour. And now we always give the last 15 minutes to Q&A. Are there any questions out there? Petra, if you want to come back on, and Devin, we have a few folks from Panzura that can also manage your questions.
All right, Glenn, yes, there are. Let me read you a few, and we'll run through them one by one.
Great.
So Travis would like to know, are any other service providers supported? And he's given an example of Backblaze, which is a backup option.
So the object stores that we've tested with are in our release notes. We've recently added OCI, so that's Oracle Cloud Infrastructure, but we support, I don't know, correct me if I'm wrong, Petra, somewhere between 19 and 21 or something like that, different object stores. But the one that was mentioned, I'm not aware of. So it has to be an S3 compatible backend object store for us. If it's something that's needed, let us know, because as long as it's S3 compatible, we just have to modify the way that we're doing logins, because everyone does logins differently, and we can get them on the supported list.
Got it. All right, next question from Cliff. After a global HA filer takes over, how do you fail back from the global HA filer to the filer that was inaccessible after the site regains connectivity?
Good question. So all of the filers have all of the metadata. And this is actually a really neat thing, which is I'm gonna fork off on the answer. Once, let's say New York went down and then it comes back up, that filer is then re-added to the ring. It's telling everybody, hey, I'm back. What are all the changes? And it downloads all the updated metadata changes. Once it's resynced and can take over its own locks, administratively, all you have to do is move that lock management over from the global HA back to New York. So it doesn't take much. Here's the fun part beyond that. If we get hit at the hypervisor level and at the VM level with ransomware, To reinstall a filer locally, you're talking about 10, 15 minutes, right? Because again, all of our metadata is saved to the backend object store. You bring up that filer, you point it to the backend object store, you tell it its own personality, and it comes right back online, right, to take over the workload. So we wrote a white paper actually with Varonis on how we all work together. And one of the things that I did within that white paper is every possible failure scenario and how we recover from a lost hypervisor, from a lost VM, from a lost server, the whole 9 yards. Hopefully that answered that question and more.
Okay, next one from Brian. I can actually answer this one myself. When will we be able to upgrade to CloudFS 8.1? Was postponed pending a hotfix for you. That hotfix should be out this week, Brian. I will send you a note when I know exactly what day, but you don't have long to wait at all.
Yeah, 8.1.1 is, it should be sometime before Friday or on Friday.
Exactly. Okay, next one from Jeremy. This is a good one. Can cloud mirroring be used to migrate from one cloud vendor to another cloud vendor?
One cloud vendor to another cloud vendor, it's not the intended purpose, but it can. That's what my engineering team told me to say. That's not the intended purpose of the feature, but it's something that can be made to happen.
Do you want to? We've got some time, Glenn. Do you want to spend a minute talking through how that might work?
Yeah, cloud mirroring isn't magic, right? So if you turn it on, let's say that you have 1 petabyte on the back end with AWS S3. When you turn on cloud mirroring, it's not to, let's say, GCP. It's not like we magically move 1 petabyte from AWS to GCP. This is going to take a minute, right, to replicate that data set. And that sync is going to take however long it's going to take. And we have various scenarios that we're going through with customers that are doing this. There's ways in which we want to limit the amount of egress associated with that. For example, in a new configuration, it's really easy, right? You have 2 object stores, they're both empty, and you go. But you want a lot of bandwidth, like especially if you're dealing with a petabyte, right? So you want a lot of bandwidth. And I think Devin, if you're still on here, I think some of this came up that you may have wanted to talk about.
I'm on.
So it's going to take a minute to move that. And you want to make sure that you are going through a facility that has the bandwidth to do that, and you have the bandwidth to do that. So did you want to add anything, Devin?
Yeah, absolutely. So architecturally speaking, bandwidth or throttling of the bandwidth is very important, because when we do a cloud mirror, you essentially double the write throughput that's going out to the cloud, right? So your outbound traffic is going to double. So there is a mechanism inside the new code that we push out to our management of the Panzura nodes themselves to allow for throttling of that bandwidth. So for traffic shaping purposes, you could limit that secondary object store, but you could also burst after hours. So you have the capability of bursting and throttling between, let's say Monday through Friday between 8 a.m. and 6 p.m. And then from there, you can kind of open up the bandwidth to go ahead and now sync more data when it's not business hours, right? So you have the scheduling of the bandwidth throttling built into the new operating system for Panzura. That's a good way to manage that.
Yep. Yeah, we have a lot more pre-flight checks before people turn on cloud mirroring with existing implementations, because it could choke your network as intended, right? Because it's trying to move the data.
Okay, looks like we're running to the end of questions. I have one from Abraham. You mentioned Nutanix AHV support at the end of March. Can you describe the benefit of going direct to AHV instead of ESXi?
It's free. Other than that, if you are a Nutanix customer AHV doesn't cost you anything, and they are catching up from a functionality standpoint with VMware. Of course, VMware has been out longer and it has a lot more management functionality and it has a lot more feature set, all of which you're paying for compared to Acropolis or AHV. So if you're a Nutanix customer, AHV is great. We're talking to quite a few of our customers now that are going that route, that are deploying Nutanix gear globally, simply because it's easy for them to manage and centrally. And they want to use AHV because it's not going to cost them anything more, but VMware would. That's really it. We're agnostic. Again, we support Hyper-V as well. So for the Microsoft shops that have Microsoft enterprise agreements, and Hyper-V is part of that, that's effectively free to you as well.
Perfect. Okay, and what looks like the
not
last
forget the
one?
cloud, right? We can also deploy in cloud, AWS, GCP, and Azure as well. So all of those hypervisors are fully supported.
Yep.
Okay, last question. What impact does cloud mirroring have on egress costs?
None. Our cloud mirroring function that's why I said that we cache. So if your primary goes down, we're still caching all the writes at all the edge locations, waiting for the primary to come back up. And so we push all of our writes to the primary once it comes back up. So there's going to be no egress from the secondary to the primary. We've implemented a lot of technology to save you egress costs within CloudFS. The only time that you're going to have an egress fee is if you're an existing customer of ours and you have 200 terabytes and you want to do a cloud mirror and you don't have a dedicated pipe to, let's say, AWS, where they don't charge you egress, then you're going to have an egress fee to mirror that 200 tera. That's a one-time hit that you're going to have to take to enable cloud mirroring. If you're a new customer and you're looking at this, then absolutely none, no egress fees. And if you're a Wasabi customer and you want to mirror to somebody else, no egress fees for you either.
All right, it looks like that's all the questions we have so far.
Awesome. Hopefully this was helpful. And I think I have one more slide. Don't miss our next webinar. Kieran, one of our cloud architects, is going to be talking about becoming ransomware proof. So we're really hammering this home because a lot of our prospects don't believe us that we're completely immune to ransomware, and we are. We've helped quite a few of our customers not pay any ransoms because they're able to able to recover. So we are very proud to say that none of our customers have ever paid a ransom to recover from ransomware for data that was on Panzura. Data that was not on Panzura, however, they were not so lucky.
Travis says he believes you. That's why he sleeps well at night.
Awesome. Thank you, everybody. If you want to have a chat, there's my contact information, gshok@panzura.com. Feel free to reach out. We can go through all the techie stuff and architect whatever you'd like. Look forward to chatting with you. Thanks.